Hey guys, look at you going through these units like it's nothing. Today we're on Unit 8. We're starting Unit 8, which is on statistics. Our first lesson is 8.1, which is called Summation Notation. Our objective is that students will be able to use sigma notation to find given summary. Now, when you see sigma notation or summation, it is just this little sign right here, this little kind of E, a Greek looking E. So it says, much of your work in this unit and the next unit will deal with situation where a large quantity of numbers will need to be added. In order to specify these addition or summarize it, we introduce a new notation which we're calling summation or sigma notation. So we're dealing with a lot of addition this unit and our other unit. So a summation or sigma notation, it looks something like this, where f of I is a function, and that's called our index variable. It can be I, it can be any letter. This kind of corresponds to here. Then it says it starts at A, and then this number at the bottom is where it starts. And then here is kind of where it ends. So what we're going to look at is the first few example is evaluate each of the following sums. It says the summation of I equals 3 and 5 of the function 2I. All that means is wherever I see I, I'm going to start with 3. So I'm going to have 2 parentheses 3 plus 2 parentheses 4 plus 2 parentheses 5. And I'm stopping at 5. Remember, this is my stop. And this 3 is where my starting point is. Then I'm going to evaluate this. This becomes 6 plus 8 plus 10, which is equal to 24. And that's my answer. Nothing else. Now, if I look at this, it says the summation of k equals -1 to 3. And the function is k squared. So this becomes parentheses -1 squared plus 0 square plus 1 square plus 2 square plus 3 square, and that's where I'm stopping. If I was to add this, I get 1 plus 0 plus 1 plus 4 plus 9 equals to 15. That's my final answer. For C, notice where my J is. Now I'm dealing with J. J is equals to -2 to +2, and it says 2 to the J power. And J is in the exponent. So this becomes 2 to the -2 plus 2 to the -1 plus 2 to the 0 plus 2 to the 1 plus 2 to the 2. Then I'm going to simplify this. This becomes 1/4 plus 1/2 plus 1 plus 2 plus 4, which is the same thing. And if you do this on your calculator, it is 31/4. And that will be my final answer. So our key thing here is wherever I see the variable, or what we call up here my index variable, in this case it was I am going to replace it with these numbers, my starting number and my ending number. What I want you to do is go ahead and pause this video and try D, E, and F. All you're doing is substituting the value. I know you can do this. This is a piece of cake. Go ahead. So now that you got a chance to try these, you should have gotten D as -1, E as 9, and F as 20. If not, look at what I worked out and try to find your mistakes, okay? Now, let's see what this looks like on the regions. It says which represents the value of this. So, which represents the value of this function? Again, I'm doing summation, so I know it's going to be add. So I'm starting at 1, and then I shouldn't use black. I'm starting at 1, and then I'm going ahead and I'm going to be ending at 4. So it becomes 1/1 plus 1/2 plus 1/3 plus 1/4, right? And then what do I get? This equals 2. Now, what you need to do is put this in the calculator just like this. So you got a chance to put this in the calculator. Remember, CTRL and division will give you a fraction, okay? Put that in your calculator. You should have gotten 25 over 12, which is choice number 3. This is extremely important. CTRL and the division sign will help you be able to get this out. Now, moving on, it says consider the summation given by this. Write this summation in simplest form. So what this is a combination of what we have been doing, probability and summation. So it says the summation when I is equal to 0 to 3, and it gave me this is, think of this as my function. So what am I going to write? The first one is going to be C30 x to the, it says 3 minus I. So my first I is 0. So this becomes 3, this is y0 plus C31 x2 y1 plus C32 x1 y2 plus C33 x0 y1. So remember, all I'm doing, and let me get a highlighter here for you, is substituting them into this function right here. Now that I want to simplify this first one's we can do on the calculator. This becomes x to the third, that's this one right here. Second one, in the calculator, you can do this part of it in the calculator. You will get plus 3x squared y. Then let's see this right here. Works out to be plus 3xy squared. And then the last one, which is here, works out to be plus y. I'm sorry, this should actually be 3 because it's y to the I power. And this should be y to the third. And this ends up being my final answer. So again, you're just substituting this. It says write a binomial expansion that this sum can represent. So remember we talked about binomial expansion in unit 6. How can I find a binomial expansion? So pretty simple. We know that this is actually going to be x plus y to the third power. The 3 comes from the number on top, and it's x plus y. There's no number in front of x and y, and we're doing addition because here is the summation. And that's it. Now, before we move on, it's always good to be able to place sum in sigma notation. These answers, though, will not be unique. So we're kind of think of it, we're going backwards. We're trying to, in these example, in the previous example, I gave you the function and you found like the series or the sum. Now, for number 4, A, B, and C, I'm giving you the series or the sum, and I want you to write something that my final answer should look like a notation, a sigma notation of something with a function. So let's look at this. If you see 9, 16, 25 all the way to 100, this is my endpoint. What do you notice about these? These are actually perfect squares. This is actually 3 squared plus 4 squared plus 5 squared plus blah 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 10 squared. So you know that's the pattern. So you know it can be whatever letter you want to use. It can be I equals, I'm starting at 3 and I'm ending at 10. And what am I doing? I'm taking that number, whatever I is, and I'm squaring it. So if I was 4, this becomes 4 squared, which is 16. If I was 10, it's 10 squared, which is 100, and that's where I end. Now B gets a little bit more tricky. It's not as easy. If you look at B, -6 plus -3 plus 0 plus 0 plus 0, it says notice that each term is 3 more than the previous. So from here to here, what did I do? I add 3. From here to here, I add 3. From here to here, I add 3. From here to here, you know, we're going to keep going ahead and add 3. Now, so I know my summation is going to be something. I know I'm going to start at 0. Where do I end? I want to end at 15. But notice my starting point is -6. So when I write my function, I have to start at -6 plus 3i. How do I know it's 3i? Because these are all adding 3. So I'm starting at -6 plus 3 times, let's say I is 1. 3 times 0 is 0, so I will get my -6. But the question becomes, where do I stop? What's this question? This has to have something up here. I want to know that this here has to give me 15. So we're going to test numbers. Let's say it's 5, right? Let's just assume I is equal to 5. What would this be? -6, sorry, plus 3 times 5. 3 times 5 is 15, right? So this becomes -6 plus 15, which we all know is what? -6 plus 15 is 9. That's not where I want to be. I want to be at 15. So you know it needs to be higher than 5. We can go ahead and try, I don't know, let's say 7. I is equal to 7. So this becomes -16 plus, why did I put parentheses? -6 plus 3 times 7. This is -6 plus 21, which will give me 15. So I know that in the top here, my ending point will be that 7, and this will be my final answer. Okay? Now C, one more. What do you notice here? 1 over 25th. You have to be able to be observant. Look at what it's asking. Look at what it's telling you. So if you look at these are all multiple of 5. So you know it has to do something with 5. This is actually 1 over 5 squared plus 1 over 5 to the first plus 5 to the 0 plus 5 to the 1 plus blah 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 5 to the fourth. Now this can actually be rewritten. We talked about this. When I want to make the exponent negative, this can actually be written as 5 to the -2 because these two mean the same thing. To make this positive, I take it to my denominator at the bottom. This is 5 to the -1 plus 5 to the 0 plus 5 to the 1 plus blah 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 5 to the fourth. Now how do we write summation? I am starting at I equals -2. That's my exponent. I'm ending at 4, and it's always 5 to the something power. This becomes my final answer. Now, what does this look like on the regions? Here we go. Which of the following represents the sum of 3, 6, 12 plus 24 plus blah blah blah? You need to be careful. You need to look. Look at what's going on. 3, from 3 went to 6. It's adding 3. Then, but how does it go from this to that? Something doesn't look right here. How do you get from 3 to 6? We times 2. Times 2. Times 2. Good. If you notice, it times 2 works. So you know it's going to be something times 2. So where are you starting? Summation. I equals 0. But remember, you have a starting point. Your starting point is at 3, your value. So this becomes 3. And then I'm adding 2i. But where do I end? I end to the fourth power. How do I know this? Because this is the same thing as if I was to factor a 3 out of this. This becomes 3. What's left over? 1 plus 2 plus 4 plus 3 8's 24. And then 3 divided by this is actually 16. So if you notice here now, they're all in terms of 2 to the 0, 2 to the 1, 2 square, 2 to the third, 2 to the fourth. So that's where this came in. Alright, so this ended up being choice number 2. Alrighty, This wasn't that difficult. Listen, you just have to be able to identify your patterns, all right? You know what to do. Go ahead and try those problems. Good luck, guys.